For example, this is a context-free grammar. Left hand side, we can have only one letter. On the right hand side, we can have how many letters? There is no limit. Okay, so we can have 2 or more letters. So here we have 3 letters. So this becomes a context-free grammar. Okay. So regular grammar means you have restriction on the left hand side, you have restriction on the right hand side as well. Context-free grammar, we have restrictions only on the left hand side. There are no restrictions on the right hand side. Okay. So and then we discussed about regular languages, and we solved question 2C. Okay, that was on last Thursday lecture. 2C we solved, and I left it here. Okay, but this I have given here. There was no time to tell you this. The answer that we arrived for 2C is actually not a regular grammar. It is a context-free grammar, because you can see the S rule has 4 letters. Okay, but your question says for each of the following regular expression, write a regular grammar. So what we need to do is we need to improvise this solution. We need to improvise this solution. To me, actually, it's very easy. I need to make some changes here. I will end up with regular grammar. Okay, but this I will do it on this Thursday. Okay, so how I will show you how to improvise this into a regular grammar, and then give you directions for solving A and B. Okay. B I will show you in class, because B answer is very similar to C. Once we know C, we can arrive at B. Okay. Then I will give you directions for A. Okay. Because I want the other batch of tutorials under Yogesh Friend, the tutor is also there. Because I don't know how good he will be able to explain this. Okay. So I will do it on Thursday during lecture when everyone is here. Okay. So what I will do is we will continue with solving question number 1. Question number 1, A we have done in class. B also we have done in class. C is for you to do it at home. But after doing it at home, no need to submit the answer anywhere. Okay. But this is for you to learn. Okay. At least do some problem solving at home with your assignment group. Okay. Then question D we have solved. So as we solve, I also upload it on my times. So whatever we have solved so far, I just name it as tutorial discussion. It's already there on my times. Okay. So whatever we have solved so far. So my expectation is you are supposed to go through them, at home, and try to understand and learn. Okay. So this is I don't want to say this. This is not a school. And I don't like to do a policeman job. Okay, did you did your exercise at home? Can you show me? We have no time for all that. This is a university and you are in second year. Okay, so you have to be independent. Okay, you take responsibility for your actions. Okay, so we have no time to babysit you all. Okay, I'm not a babysitter. Right? Sorry to say that. So why I'm saying this means if you understand this subject is a cakewalk. Very easy to get a. You don't understand, it's going to be a nightmare. I tell you, it's going to be a nightmare. Okay? Yeah. It's easy to understand. Once you understand, it's nothing. People, there are haters and lovers. That's what they send me an email when they leave the university. Okay? Yeah, there are a lot of lovers, but there are a few haters as well, because they don't follow the class, so they don't understand anything. Okay? If you don't understand, as I said, it's going to be a nightmare. Alright? Okay. So A, B, C, D we have done. Up to here the answers are also there at my times. So I'm going to explain 1E and I'm going to show you. I'm going to give you directions for 1F and 1G, and I expect you to solve it in the class. Okay. So let's run through 1E. Yeah? So 1E says the languages A length n, B length n, where n is greater than or equal to 0. So what this means, A length n, B length n means A length n, B length n means when n is equal to 0, what will happen? Empty string. When n takes a value 0, it means A length 0, B length 0. When is A repeated 0 times, B repeated 0 times. So you get empty string. Right? When n takes a value 1, A length 1, C length 1. I don't read it as A power 1. Huh? Yeah, I read it as A length 1. Okay. So you may ask, what is the difference between length and power? So instead of taking A length n, I take, you can also take numbers, not necessarily it has to be alphabets. So what happens if I take a number, alphabet, I take 2. Because in the number system, the alphabets are basically 0 to 9. Yeah, decimal number system, right? So I take the number, decimal number system, so I take 2. And if I take n, so what happens if n is equal to 2? In theory of computation, when we read this as 2 length n, okay, 2 length n, it means this 2 is repeated 2 times. This n is repetition, or it defines how many times this is repeated. Okay, so if n is equal to 2, this means 2 length 2, meaning 2 is repeated 2 times. This is a string. This is the example string. 2 length 2, it means 2. You understand me? The length of the string is 2 characters. So it is 2. In mathematics, when you read this as 2 power 2, you go and show this to your mathematics lecturer. My time means my times like you means I say 2 power 2 is 22. To my lecturer, I would have seen stars. What do you mean by saying seeing stars? One slap. It'll take a few minutes to realize where I am. I would have seen many colorful stars. Honestly. Okay. My year notes have gone red before I finished my mathematics class. Yeah. So my mathematics lecturer will hold the year like this. Don't worry, I will hold the year like this. Make one round like this, one round like this, keep on twisting like this, right? But before he finishes, I would have, almost got up from my chair because I cannot sit. The ear will be like a red cloud. Okay, that's the way we learn. Today, no, and if we do that, I think we will be great bars. Okay, now fine. But I don't regret. Okay. The hard way I learned, I remember a lot of things. Okay, I don't forget easily the subject. Okay, so I really understand the difference between power and length. So that's why I consciously read here as length, A length and B length, and I don't read this as A power n, B power n. No, because n is going to take values. Okay, yeah. All right. So now you know what are the example strings. So immediately we have understood what is A length and B length. So we start writing example valid strings so that we can see what pattern of strings this language produces or accepts. So it's going to accept lambda because n can take a value 0. If n takes a value 0, we can have lambda empty string. I can have AB. If n is 1, if n is 2, I can have AABB. If n is 3, I can have triple ABB. I already see the pattern, so I can stop. But also ask how many example strings I should see. There is no feng shui number for this. There is no definite number for this. Okay. We stop once we see the pattern. I just stop with 3 strings because I already see the pattern. What is the pattern here? A is followed by B, and the length of A and B is always equal. A is followed by B, and the length of A and B is always equal. If A is 1 time, B is 1 time. A is 2 times, B is 2 times. A is 3 times, B is 3 times. It's only one pattern. There is only one pattern, I just stop with 3 strings. So I'm going to reflect this thought or translate this thought into production roots. So as usual, what I do, I take the smallest possible string as my rule, first rule. So S is lambda means I can produce this string. If I take S is AB, I can produce this string. But how to produce AABB? Correct, right? But this AB, if you observe carefully, is already here. Is already here, right? If I take like this, I can only produce S as lambda, S derives lambda, S derives AB. I cannot produce all these valence strings. I should be able to produce all valence strings. Okay? So my thinking is, I have already taken S as AB. Right? So my example strings are lambda, AB, etc. So if you observe here, when I take S as AB, this AB is here. So to me it's a recursive definition. AB is here. If I hide this, I have another AB. It's something like built-in, picture in picture. AB is built inside another AB. That AB is built inside another AB. So what happens when I take S as AB, I can replace this as S, right? So I am improvising this rule. Looking at this, I am improvising my rule as. So now you may ask how to produce AB. You cannot derive S derives AB. I have to, since I have changed my rule, I have to write like this, A as B. And in the next step, what I can do, I can eliminate S with the lambda rule, I get AB. You all follow me? So, with this rule, I can produce any number of A's and B's I want. For example, I want to produce 3 A's followed by 3 B's. I simply say A as B. I have A and B one time. I need to have 2 more times, right? I just expand this further. I expand S as A as B again. This A remains. I replace S with A as B again. This B remains. The next step, these two A remains. I am going to replace this S with A as B. These two B remains. In the next step, I can eliminate S with the lambda rule, so I will get triple A. Done. So that's my answer. This is one way of writing the rule. You can write it other ways as well. This is one possible solution. I'm just highlighting it to say that this is my answer. Okay? So, if you observe, these two are similar to this. Similar, not the same. Okay? So similar means they have a lot of similarities, common properties. Okay? So if you observe here, if I hide this part, it's the same, right? If I hide this part, this and this is the same, correct, right? But if you see the loop variables, here n can grow from 0 to infinity, and m can grow from 1 to infinity. Minimum value m can take is 1. Minimum value n can take is 0. Maximum value n and m can take is infinity. Okay. So what can be the smallest possible string here? What can be the smallest possible string? C, right? Yeah, absolutely. So we can have 1C, 2C, 3C, etc. Right? So C alone can grow because when you keep n as 0, A length 0, B length 0, this part of the string will become empty string. Okay? Concatenated with followed by C. Because some students are, hey, this is empty means 0 la. 0 into C is 0 la. Of course, we know 0 into anything is 0. We are not doing mathematical multiplication here. Okay? This should be read as A followed by B followed by C. It is not A into B into C, no. Okay? So when this part of the string becomes empty, it becomes empty, that's all. You will still have C. Okay, so if m is 1, c will be, 1c, string will be 1c, if m is 2, c will be 2c, m is 3, 3c, and so on. But not necessarily n has to be 0 when m grows. What I'm saying is m can grow independently and n can also grow independently. They can grow independently. Okay, so when n is 0, c alone is going to grow. What happens when n also grows? What happens when n is 1? So the next possible, smallest possible c could be n is 1, m is 1. So you will get a, b, c. Correct, right? You can also get a, b, b, c. So n is growing, c is fixed there. Okay, we can also have a, b, c, c. We can also have a, b, b. I just stop. I just want to see the pattern of strings. Okay, so the pattern of string is purely C's, or A, B, and C grow independently. So I have given here. N is 1, M is 1, then you get A, B, C. If N is 2, M is 1, you get A, B, B, C, C. When N is 1, M is 2, you get A, B, C, C, and so on. Okay. So to me, my thought is, I have this part of the string is the same as this. So what we human beings do, we follow the monkeys. Monkey see, monkey do. Okay? So we just ape this. Ape this means we just mimic, reproduce this answer here for this part. This also is AP. This is different AP. Okay. So I know some of your face, I see you are lost, and I say for this part of the string, we can apply this answer. And we have to write the production rule to produce one or more C's. Any idea? Okay, I give you directions, you think. I am going to take this part as capital A. Okay? And this part as C. This part as A, capital A, and this part as C. Maybe I'll show you, I'll fill in the blanks and let me see to what extent you can build on it. So what I am saying is, take this part as A and this part as capital C. That is. So for A, you apply this answer, not just copy paste it. When you apply this part, and for C, you have to see how to produce one or more C's. If you want to have one C, I want to grow 2C, 3C. Right? So you want to grow, you can replace capital C as CC. So we call this as recursive definition. Recursively, you can produce any number of C's you want. So we have tackled this part. We have to tackle this part. This part, the answer is already here. So what we should do? This part can be lambda, right? Can be lambda, right? Empty, right? You can have only purely C. So what happens if I want to have AB? Exactly. You take it from there, but if you take it from there, will it work?
No, not exactly.
Not exactly. Maybe.
It works.
It works. We have given 3 answers.
Itu my last answer.
It works.
It works.
Are you sure it works?
Yes.
How to verify? What I'm trying to tell you guys is, you can verify yourself by doing derivation. That's all. AC. So I can replace A as B. Capital C remains. So I have replaced A as B. Capital C remains. The next step, I can actually fold the derivation. Not necessarily I need to go in one line. So if I just want ABC, what I can do? I still follow leftmost derivation. I replace the S with lambda. AB remains. Capital C will remain. The next step, I can replace capital C with small c. I get ABC. Okay. So if you want to grow, you can grow also. The next step, I want to grow. So I replace S with you see now you are stuck. That's what I want to show. When you do this, you will know where your problem is. Now, when you replace, you want to have BBC. ABC. If you want to grow, replace S, your only possibility is AC. You already have a C here. You already have a BC here. Sorry, BC here. Okay, you will end up with A. If I replace A with lambda, I'll end up with AC, B, capital C. Maybe I'll end up with AC, BC is an invalid string. That's why I said you should copy this idea, but not the grammar itself as it is. So what we should do? Now you realize, right? Where is the mistake and what to correct. That's why I said you should do this. If you do it here, you have just started to learn. Okay? You may not be able to see the mistakes. When you do this, then you'll know, oh yeah, I have a problem. So with the problem, you know what is the cause of the problem, you can solve it. So you should replace S with A. If you replace S with A, now you see what happens. You have just followed the same idea, but not copied the rule as it is. You are following the idea, but not the answer as it is. So now this is capital C as well. AC. So I'm going to replace A with AB. This capital C will remain. If I want to grow this AB, I can replace A with AAB again. So replace A with AAB again. This B remains. I'm just underlining to show what is happening here. This capital C remains. So I can eliminate A if I don't want, applying the lambda rule. So this will end up with A, B, B, C. As I said, always do one step at a time, don't jump. Maybe I want to terminate C with a small c, I get A, B, B, C. So you can grow A independently like this, you can grow C independently like this. So this is your answer. Okay. Done, huh? Yeah, done. So how to do G? If you do G, you can see a lot of similarities with the earlier two questions. So here, A and C are always equal. You see, A length n, C length n. So length of A and C is always equal, right? And B grows independently. Because B here, length of n is greater than or equal to 1. Length of m is greater than or equal to 0. So B can grow independently. So example, valid strings could be like this. I can have 1B, 2B, 3B, etc. Or I can have A, B, C. I can have AA, B, C, C. I can have triple A, B, triple C. I can have A, B, B, C. I can have A, triple B, C, etc. So I can have purely B's. Then A and C grow equally. Length of A and C are always equal. And B can grow independently. So I can have A, B, C. I can have A, B, C, C. So here I have kept B. I am growing A and C. Here I am growing both of them. So what to do? Similar thought. I need to produce B's. What should we do? Terminals or non-terminals? Non-terminals ABC. Okay. ABC can be recursive. Can you try? Done already. Oh my god, very fast. Can you share it? There should be a so everybody can see.
The line spread should be showing.
Dạ, thầy chỉ cho bài làm bài thử. Đến sức lên, rất là tốt.
You have to select the input first. And then there's another button there for doesn't move. It stays like that.
Oh,
Actually, all should be able to see it.
记得吗？自己
It was so funny.
这个，这个是一个。
Either produce more A's and C's or
简称是吧？
有 A 吗？有 A 吗？
还有点话。
expand A, that's easy. That's easy. You can go the
这
A's
三
and
方
C's.
不够。对啊，我就觉得我是对的。差不多，就像你。
I got the number.
小时候叫那个带锁的那种。ABC 或者 ABC 就完了。叫塞。没有 A 几个，已经还没塞好开，一甩，就是这个这样子的。都这样，最好带。哎，
So anyone? Again, how to increase the B, and I can still grow the A and C individually. You know, I can have more A's or more C's. You can see that? I tell you, you cannot go in the direction of A, B, C, recursive definition. It won't work. lot of answers. Not necessarily one answer. Yeah.
G.
A, S, C.
Yeah, so we can duplicate the A and C together. While when you move to A, E, C, you can move here to the B.
So A, C, A, C. Okay. B.
Or you can directly just have a B on it. Or you can move C.
You can produce one B, but what happens if I want to produce multiple B's?
Here, you come here S, and after here duplicate.
No, I want only pure B's.
One only pure B's.
Or then I only produce one B only.
So this is regular grammar. So right hand side is only message and two letters. Right? The answer again. So you see the letter is for non-terminal. So the two letters is like this answer, right? Is A, capital A, C, capital A.
It has 4 letters now.
Two letters. But this one
I have only 2 letters now.
So yeah, wrong.
This one is. I'm not saying it's wrong. This is not the answer yet. This is actually a context-free grammar.
Oh, it's not regular grammar.
It's not a regular grammar yet.
Oh.
It's a context-free grammar. It's not a regular grammar. That's why I said we need to improvise this to convert this context-free grammar into a regular grammar. No, you have still 3 letters. Only 2 letters. Whether it is uppercase, lowercase, doesn't matter.
So that matter. It's like B and C, the minimum as well.
Yeah, 2 letters.
Actually, oh.
No, like it doesn't work. Sir.
Okay, so if I change to E, then okay lah.
Change to E also. You change to E also.
Change to E.
Now, you change to E, you can only produce B. Right? Purely B's you can produce.
Yeah.
Yeah, but what happens is, I can go to E and produce purely B's. So what happens if I want to have A, S, C, and I replace S with E, A, E, C? Well, this one is already here. I can replace S with E, right? Why you want to have this?
Oh wow.
Correct, right? Redundant, right?
Yeah.
I mean, it's not wrong, not necessary. Correct, right?
Yes.
Okay, can you write on the board?
Some. 等一下，好的，算了。
Okay, one possible answer. I give you a clean board. So can we give a round of applause for him? So I want everyone to volunteer, to come forward, to share your answer. Okay? This is one thought. Okay? It doesn't mean this is the only answer. This is one thought. Okay? So if you ask me how it works, let me show you. You have pure B's, right? You have pure B's, right? So what happens if I want to produce purely B's? So I can simply say, yes derives, I go here. You can use E, any letter you want. Okay? You can use any capital letter. We call this as non-terminal. Non-terminal means uppercase. You can expand them. Alphabets are terminals. You cannot expand them. Okay? The small letters are usually alphabets. You cannot expand them further. Instead of E, any letter you can use. Okay? So I I want to produce one P, I go here. Because S is A, S, C, or E. So I take E. And I have a rule here, E is B. So I can replace E with B. If I want to produce 2B, I can do so as well. I replace S with E. In the next step, I replace E with BE. In the next step, I replace E with B. I will end up with 2B. So this is again recursive definition. You can produce any number of B's you want. Okay. With this rule, you can actually expand A and C. Okay. So if I want to have A, B, C, I can do so easily. So S derives, I apply this rule, A, S, C. And the next step, I replace S with E. So I will get A, E, C. The next step, I can replace E with B. I will get A, B, C. So you can do like this also. You can replace S with A, S, C again. This is again a recursive definition. You can produce any number of ACs you want. A, S, C. The C remains. So I replace S with A, S, C. The C remains. Right? And I can replace the S with B. So B means I have to replace with E. The next step. Okay? Yeah. So this is one easy, simple, possible answer. Okay? Let me take the attendance before my laptop also dies. Almost like that.